Yeah, so once again, I think we had pretty much finished with this part. You might want to use this in your upcoming homework to be able to read stuff. But what I want to do is I want to continue on with the daily task. And so we'll hit on the second link and we'll figure out who did the first homework right. So let's click on this link, folks, and this will take us to our first homework. And you can see in here, remember I had asked you to put one line from that big data set, right? It was this data set about corn, and you had to go over there online using that what was it, a VM, to use JMP Pro and pick up one line, and then create a CSV file that had that one line in there. All right, let's find out who did it right. And of course, we're going to use ideas from databases, data analytics, and so on and so forth. Since we did it with a specific naming protocol, it will be very easy to read that back and figure out who followed the instructions. All right? To see how that works, let's go ahead and open up first off, download the whole folder somewhere in your desktop. Remember, it's a good practice if you're starting a new project to download everything, create a new folder, and we're going to run from that. So go ahead and do that first. Hit the second link that you got here and download everything here. And you can name it homework 1 or whatever. And save it somewhere in your desktop, okay? We are in the daily task of last week. Hit the second link and then download and save it. Download all these folder somewhere. That is not needed, but if you hit the download all, I can download all. I'm going to zip them and download them, so you might want to unzip them afterwards. You could download them by drag and drop all of them, or so go back and well, actually for the day, yeah, that's going. All right. So once again, let's go back to our Moodle and hit on the daily task of last week. We finish and go to the second link. That is the Google Drive folder that had all the answers. I would strongly suggest create a new folder somewhere in your computer and paste everything in there, or download everything in there, or unzip everything in there. Now, for those of you that joined us recently, we will be using Google Drive, so if you don't have an account, go ahead and create one. Using it, lots of things are going to be going back and forth. Don't want to use emails or anything like that. So having a Google Drive helps. So once again, download everything. They might have them zip, so you need to just unzip it. Okay. And then you should be looking at a folder like that location. Yes, it's last week's daily task. Remember, we hadn't finished all of it. All right. You'd have the answers from your classmates, plus that R file that I'm going to use at the very end. Remember, the task for homework 1 was each of you had to go into that corn.dbf, open it up somehow, and we used JMP Pro last time to do that, and select one line, including the variable names in the top, and save that as a CSV file using your initials and the naming protocol that we had discussed. And now we're going to come in and say, why is that naming protocol useful? Why does it make sense to follow that? And why you should have that practice in general. So if you're looking at this already, go ahead and open up this TG multi-read merge 1.1. And we're going to discuss it a little bit. Once again, for the beginning of the class, my goal is not to teach you how to become a programmer. My goal is to give you an idea of how these codes work and also give you the codes themselves, because you can get the code, manipulate it a little bit, and make it fit into other stuff that you're working on. So once again, what I would like you to do is I would like you to put comments in this code as I'm going through it, and we'll figure out what it does. All right, are you all with me? Let's see. Wait a minute. So if you downloaded that folder, it will have a bunch of stuff, and then save it somewhere. Yep, so you have to unzip, open it up. Go back. It's probably easier there when you're download all. Download it, takes a while. If that doesn't work, then what I would like you to do is I would like you to grab all of these. Open it up. And then you right click on it. Right click on it. Yeah, this one. And then you have expect all. Alright, and then give it a piece of name in all case. Nonsense, so it's still over there. Rename it a little bit easier. Set it somewhere. And then we're opening up the EG something from that. Right? Very good. Now, before we even start, a couple of things, okay? The reason why we put everything in the same folder is because we want to make use of our smart lookup of files. So go ahead, immediately, the first thing you do, hit on session on the top. You see that little tab, session, set working directory, source file location. You need to do that every time before you start. Remember, we need to tell R where the data is. If you did our job right and put everything in the same folder, using this little trick, it knows where it's at. Otherwise, you need to put the whole path. Again, where is it? Oh, the previous one, it was blah blah blah. The second one. We finished the first one, but we hadn't checked the home one.
And the TG core.
TG multi-read merge, but download everything because we're going to need the data from that one. Okay, so immediately first, when you open up an R code, make sure you tell it where to go and find the data. Okay? Right? Now, new file, download it from the left, go to new, find the data file, download the Right, so session, set working directory, source file location. Right? For those super eager, you can just run the code and see the marvel. What it does, the whole thing should work. But what I would really like us to do is go line by line and try to figure it out, put the comments, try to explain it to ourselves. Should I wait a little bit or everybody's on board? I see a lot of folks there. Not everybody. That's a good question. If you have already downloaded it, you don't need to install it again. But you do need to make it here. Right? So if you're looking up there, the first library I'm calling is library easy packages. Remember, that is a package that handles packages. Make sure that there's no conflicts. We said if you already have downloaded easy packages, it's just going to work. If you haven't, bottom right corner where it says packages, click on install, and start typing in easy packages. But I'm pretty sure you already have that because we did that last time. Having said that, I don't think we have Tidyverse, and we might not have ggplot2. So let's go ahead, because as you can see, I'm going to install these packages later on. So let's go ahead and try to install those. So go bottom right corner and hit on packages, and then install, and then start typing the names of these libraries. Okay, one by one for you. These are just R, right? And then respond to R. We want this have you downloaded this already? Right. So once again, I'm going to need library easy packages. If you don't have that, put it. I'm going to need libraries foreign, Tidyverse, and ggplot2. You have to install one by one if you have not done that already. But even if you have done that already, it doesn't matter, right? If you reinstall it, you're probably getting the fresher version. Go ahead and do that. Don't take too long. Tidyverse is a little bit large. Therefore, I'm not going to install it again in the future, but it's very, very useful. The idea is for Tidyverse, there's so many packages doing the exact same thing. Folks were like, all right, let's figure out which one is the best package that does this or that. And then they collected all those and created what we call the package. This has a collection of all packages that have been checked, safe, and they're best in what they do. So it's got a lot more packages in it. And ggplot2 is the one that I primarily use to do graphs. So great graph plot. All right. Any problems with installing them? Remember how it's done? Bottom right corner, packages install it. Great. So basically that's what these first two lines do. The first one calls the package easy packages, and the second one calls the other three. What about the very top one? Let's run that one line, and notice what's going to happen on my global environment here on the right when I run this command. So what does this command do? It cleans everything. All right. So it's a good idea, especially if you're doing big data applications, to make sure that you delete everything that's in your environment prior to starting a new project. And this one basically removes everything. RM list equals list. So put a little comment right next to it. That's what I would like you to do. As we're talking about the code, I would like you to go in and put in your comments. So what does this one do? It deletes everything. It gives you a clean start. Then if you run these two, you'll have to run them again now. These load back the packages. All right, so run the first 3 lines and you should be on board. Great. Now the next 2 lines we've already used in the previous example. Let me remind you of what they do. In the previous one, we used them to read all database files. This time, I want to read all CSV files, right? Because if you remember, each of you had to put in a CSV. The idea is the same. You use the list files and you just tell it what pattern you want it to read. Your pattern is star.csv. Star means it's a wildcard, right? It means anything that ends with .csv. So the next line, the temp equals list, basically scrapes the name of all the CSV files that the program sees in that folder. Okay? And stores them in a list. That list is named temp.
List out files is like a scraping function.
Yeah, this one is basically list the files that end with CSV. All right? So that's what the line number 5 does. That did not read the files themselves. That just learned their names. Agreed? The line that reads the files actually is the next one. Remember the lapply? The lapply basically is give me a vector and something to do it, the function on it. So the function in this case is read.csv, basically read the CSV. But then you don't want to do it in each separately, you just want to do it in all of them together. Since you've scraped all the names, the lapply says, read the first thing that you see in that list. Then go ahead and read the second thing that you see in that list until you exhaust it. And you also save these as a big list. That list has a name, my files. All right, so let's go ahead and run that one. And you'll see now, so let's run line number 6. And you'll see that something bad happened because I haven't set the session to the sort of working directory. Run. Okay, so now I have 12 different files that end with CSV, and I can see that by looking at this temp variable here. And then my files is a big list that have 12 entries in it. Each of these entries is a data frame. You can see that by look. If you go to the environment over here, it should have my files, right? Click on that one, and it tells you that my files is a list of data frames. Let's see if I can make this a little bit bigger. Okay. So over here on the right, you have this new data set called My Files. If you click on it, you see that My Files contains 12 elements. And if you click on the first element, you see that it's basically a data frame that has only 1 row. It's got 1 row and 12 columns. So basically, My Files is a list of data frames. Okay. Very good. Now, we want to make sure that you did it right. Okay. Therefore, we need to compare it to something that I know was done right. So I also created a file following the instructions, and I call that file tgcorn1501-2019 following the name. All right. So the next line, the template equals, basically reads the file that I have generated, which is going to be basically your answer key if you get it. Okay. And I call that template. Notice how you read just one CSV file, right? What's the format? The format is you put read.csv, that's the command, followed by the name of the file. Read.csv has a lot more arguments, but in case you just want to read one comma-separated value document, which is mostly what happens, this is what you need. And as long as R finds this file inside the same folder you're working, you won't have any trouble. You could specify here the whole path to get to that file if it's not in the same folder. But if you just want to keep things easy, just drop that file in the same folder and don't do anything. It does have to be within quotation. So anyway, template reads my solution and basically is going to compare everything to it. Now, what I want to do is I want to merge all of these files that you have generated and put them in one big data frame. So to begin with, I create such a data frame that has no rows and is filled with zeros. This is a good thing to do. Create tables in the beginning and then fill them in. This is programmatically sound. Instead of like creating them as you go, it's much easier if you say start with something empty and then fill it in with stuff. This is an initialization process. This is a good thing in programming. So that's what I'm doing with the clear files. I'm creating a data frame by using no rows but 13 columns. And then I'm going to fill that in. And that data frame has zeros. So basically it's completely empty. The moment that you run line number 8, first off, let me read my template and then line number 8. What you get, the clear files, is this empty table that has 13 variables. Okay? And then I'm going to fill it in with information. All right? Any questions so far? So that clear files, as I said, has no information in it. We want to make sure that the variable names that we have in my template get also into that clear files. And that's what line number 9 does. To be able to give names to the columns of a data frame, the function is call names. If you run it on its own, if you just put call names clear files, if you select this part and run it, this gives you the names of the columns of a data frame. But if you want to specify what those names are, you use the exact same function. You say call names of blah equals, and then you tell it what names you want to put in there. And this enumeration is actually quite smart. My original data set had 12 variables. I want this clear file to have those 12 variables plus your names as a 13th variable. Okay? Which I'm going to scrape from the name of the file. But I'm going to be using the same 12 variables that we had plus an extra variable. So I now want to create my clear files to have the same 12 variables that I had before plus one extra variable. So look at how beautiful it is in R. You say the column names of this new folder, this new data frame called clear files are going to be concatenate the call names of the template. So that's going to grab the 12 variables, comma, name. So this one says, look at the call names of the template. That was 12 variables. You can use those, and the last variable is going to be name. And you can do all sorts of things here. You can add names of variables one by doing those semicolons, or you can even add another list somehow. You have created some other list, put comma at the end. And as long as the number of variables that you have allocated matches the number of symbols that you put over there, R has no problem, appends them the same way. The first, second. So my next line basically does that. Renames clear files using the template call names and the extra variable name. If you click on it now, as you can see, it has yield, flow, adjustment, duration, distance, width, area, elevation, date, grower name, field name, crop name, and then name, so your name. All right, then we are checking to see who did it right and who did it wrong. It makes sense to keep a list of who did it wrong. And once again, it's good to initialize that and fill it in. So line number 10 creates an empty vector that's going to keep all the problems. Once again, it's better to create something and fill it in rather than filling it in inside the code or creating it inside the code. So that's what this one does. Creates an empty vector called problems. Okay. All right. Are you with me so far? Any questions up until number 10? Now, all these little pieces, I have used them before, and I will use them again in other codes. So don't be fixated, oh, this code does that. Use the commands on their own. If you want to scrape something, you can use something. If you want to change the names, you can use this one, all right? That's my mentality behind it. All right. So the next loop is a little bit involving. It is a for loop. For loops in R are relatively fast. Python is faster. C++ is faster. R is faster than things like SAS or Stata or whatever. If you can avoid loops, avoid them. But if you cannot, it's still, you know, for data sets that go up to 10,000 data points, they finish relatively fast. If it's replacement or something like that, they finish relatively fast. So not a big deal. All right. So what is the general idea behind the next for loop? Well, it's going to check basic stuff. Did you put one row? Did you keep all columns? Did you keep the names of the variables? Basically checks if you did the problem right. So what it's going to do is going to go through all the entries that you gave, which remember are saved in my list called my files, and it's going to check for these attributes. Is the number of columns 12? Is the number of rows 1? Basically, right? And did you keep the column names? If you did that right, you pass the check. If you did it wrong, you go into problems. All right, so let's figure this one out. For loops are basically doing something in a repetitive fashion, right? So this one says for I equals 1, 2, and ending point. So now, since I don't want to tie this down to however many people did the homework, I may want to use that next year. Instead of going from 1 to 12 or 1 to 14, I go from 1 to the length of the answers that you got. Right? So the my files had 12 answers in it, but maybe next year, 14 of you are going to respond. I don't want to be tied down and put 12 or 14 or something like that. And that's good practice as well. If you're not sure how many steps you want to do, tie it, relate it to something from the input. So length is a function that looks at how big that list is. So this for loop goes from 1 until it exhausts the whole list. And then you put a little bracket, and after the bracket is where the for loop starts. And the for loop, as I said, has an if statement. If statement is basically check to see if everything inside, whatever follows, parentheses in this case, is true. If that is the case, if statement fires up and says yes. If any of them fails, you move to the else. All right? So if everything works here, else here. So as you can see, my if statement says, if the number of rows in my files I is equal to 1, if you have one row, and the number of columns my files 1 is 12, and the names of the variables equal the names of my template. You see all that? The ends between them, this symbol says end, end, end. Then you add the name of the file as that extra column, and you put it into clear files. All right, so this last line says, remember that clear file, the empty one that we just created? If it passes all the checks, add that there. Add the one that you read, add it there. Go to the second one that you see in the list. Does it pass all the checks? Yes, add it there. and so on and so forth, right? As you can see now, it starts from clear fields and take clear files and adds that step. Our bind is the one that uses bind things one at a time. This line right here, what does it do? It adds an extra column, the column name. Right? And at this stage, it's the name of the file that you started off with. Remember, the names of the files are kept into the list temp. Right? So temp1 is the name of the first file. Temp2 is the name of the second file. So that is added inside the argument. So clear files now has your values plus the name of the file is the very last column. Let's go ahead and run it and see it. The else statement is if it fails any of that, then your name goes to problems. Right? And then it's increasing by 1. So let me run this part and see what happens. In order for a loop to run, you have to select all of it. That's why I kind of like to put these up and down things to just keep the loop tidy. You know what to grab. Remember, if you put that pound key, everything after that is discarded as a line. So it makes sense to do, convenient things like that. All right. So for me, it took like no time, but it might take a little longer for you. When I click on clear files, I see now that I have a data frame that has 13 observations, and it's literally your observations, your data concatenated one after the other. And if you look all the way to the end, if you scroll the bar all the way to the end, at the very end you have the names of the files. Are you with me so far, everybody? Okay. So, with a little for loop, since we did it right, you can check if people follow the instructions that we did. If they use one column, they use one row, how columns like 8. But we're going to take it one step further. We will isolate the initials of the folks that did it. Now, notice also that my the vector problems is null. So all of the ones that submitted the homework did it right, at least on the first step. Okay? So since I don't see any problems here, it means that everybody did it right. Otherwise, if there were problems, this list would have the name of the file that has problems in it. Okay. Now, if you look again at clear files, the very last one has the whole name of the data set. It doesn't have just your initials. That's what I'm going to try to do right now. I'm going to try to isolate your initials from this. Okay? But this is a more general thing that you might want to do. Every time you have a string basically a list of characters somewhere in R, there are many ways to pick pieces from that string. The easiest one is if that string is split apart by a special character. Right? Remember the naming protocol that I told you. Split things apart with an underscore. That's a special character. So I'm going to utilize that fact to split that big thing here and just keep the part that I care about. All right? That's what the next part of the code is going to do. So, the first line, clear files creator name equals 0, creates a new column and populates it with zeros. So that's yet another way to create a new column. Just straight up put the name of the data frame followed by $, and then the name of the variable. Right? I would love it if you could put that as a little comment right there. That's how you can create variables in a data frame in general, all right? And it also makes sense to initialize them with something. Easiest thing, equals 0. All right, so that's going to create a new column with zeros. And then you can fill it in with whatever. So this new line basically creates, creates a new variable named creator name and populates it with zeros. Once again, something that I would like to pass across. When we're doing computing, when we're writing codes, and you'll see this in Python as well, it is easier if you create something empty or something with zeros and then you fill it in, rather than creating it within the loop. Okay, so the next for loop is the one that's the most involving. So I want to make sure that everybody's on the same spot. Are we all looking at the for loop starting at line 25 or 26? Everybody over there?
We're down with all the other comments and all that. This is like the loop part. It's easier. Like you roll with the line with 0 and not with 0. Is it why? Why? What? Why do you only do 0 and you leave it empty, or why? Yeah. Well, why it's easier. When
so
you're programming with 0 or not.
Right. There is really no difference in the R if you use null or zeros. The main thing that you want to be careful of is do not create it in the loop. So it has to do with memory allocation. You're going to be creating a new column. If you haven't told R how large that column is or what to expect to find in there, he's going to try to grab as much memory as it can. He's going to see it as a list, which is a more global thing. So if you expect, you can put other tables in there. But if you do it like this, you put clear files equals creator name equals 0, then you're telling me you're expecting to see numbers or characters or something in there. Yeah. So you're basically setting it up to use less memory in the creation. That's just about it. Now, why 0 versus null? There's actually no real difference in all. I'm not sure in other programming languages it makes a big difference. I want to say in C++ it's very big. Python, but in R it doesn't make a lot of difference. The thing is, if you put zeros to begin with, then you're narrowing it down just to make it as simple as possible. If you don't create that in there and that just pops up somehow in the loop is always going to be, it's a list. It takes longer. So it's going to take longer to fill things in. Well, and again, all right, let's pause this. All this discussion was relevant 15 years ago when memory and processing power was very low. Nowadays, it actually doesn't matter that much. And with a smart and fast computer like these guys, it doesn't really matter. But 15 years ago, yeah, that was a problem. If you were to allocate a lot of memory somewhere, things would hang. You might see these problems when you're doing, let's say, neural networks with images. That's the only part that I've seen problems with memory. But for simple things like that, modern computers have zero problems. All of them are equally fast. Okay, it's not going to take 2 seconds. It's going to take a second and a half.
It's more like the weight is standard by.
That's also true. It's also good practice. I mean, you know, what if you extend this to 5 billion vectors? You're not going to do, but if you were to do that, then maybe at that point, memory would be a problem. So you want to do it like this. All right. So the next for loop is, as I said, the important one. What I'm doing now is I'm going through that clear files. Again, look at the syntax here. It starts from 1 and goes until it exhausts clear files. So it goes from 1 until the number of rows of clear files. So it's going to go through all of them. And this one has a very peculiar if statement but I'll have to break it down step by step for you. All right. Let's start from the inside. str split clear file's name. str split is an abbreviation for string split. So basically, we're going to be breaking up what? We're going to be breaking up clear file's name I. So it goes to the column name. Remember that big thing that had basically this? It goes to this. Goes to the first one and splits it by underscores. How do I know? It says split this thing using underscores. So string split is an argument that takes a word and a special character. Word, comma, special character. So this one says string split clear file's name I, so the ith entry in that column, by underscores. Okay? And then from that, keep the first, look at the splits. Look at the second split. And make sure that that is equal to corn. Right? So, let's go ahead and split this in our heads. The first one, the AN. When you string split that one, you get AN, that's your first split. Corn, that's your second split. Your third is 01. Your fourth is 15. And your fifth is 2019.csv. Okay? So, this one is abbreviated as str split name, comma, underscore 1 1. Okay? This one is abbreviated string split blah 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 1 2. This one is the same thing 1 3 1 4 1 5. Say it again. How do we write the first one? Wait. So it's so to get back the first split, you just need to put bracket 1 bracket 1. The second split is bracket 1 bracket 2 and so on and so forth. Right? So I want to make sure that you follow the protocol. The protocol said start with your initials underscore forward underscore date. So to keep on checking for errors, I'll need to make sure that the second word that you put in the name was corn. And that's exactly what that line does. It says if when you split it by underscores, the second split is corn, continue. See that? If when you split it by underscore, the second one is corn, continue. Okay? Now, this would be just the string split, would be this part. But I also have another argument over there called substring. Because some of you guys could have put corn 1 1 1, corn 1 2 3, corn 1 2 4. Okay? And I want to catch that. Because we said if you're using the same folder over and over again, you might put different abbreviations to it. So then I'm making it a little bit more elaborate. I'm not saying that the second split is 4, but I'm saying the letters from 1 to 4 of the second split should be corn. So the new command is substring. Taking the second split, and I'm looking at the substring of that. Starting from the first letter and going to the fourth letter. That should be corn. Okay? So I'm doing two computations at the same time. First, I'm splitting by underscore, and then I'm looking at the second split. Substring that from the first to the fourth. That should be corn. Now, most of you guys just wrote corn, but even if you wrote something like corn 1 to 3, it's corn. Okay? And I want to allow that because remember, in the naming protocols we have different versions. And sometimes we forget to put underscores in the markers. Just tag it over there. It's still fine. So again, that was a check. And if it passes that check, put something in the column creator name. What do you put in there? You put, again, split the clear file's name by underscore and put the first one. Remember, the first one was your initials. Right? Else, put that as a problem, save it as a problem, and put also an indicator over there that this guy did it wrong. So let's go ahead and run this next part of the code. And now if we open up our clear files, we will notice that there is an extra variable at the very end, which has the creator name. So basically we isolated the first part of that big string. Okay? Now, again, this is a tool for you guys. This is independent of what you're doing. You can use a string split to split bigger character files. Isolate something. And this only works. This only works because we did it right in the beginning. Okay? In the beginning, we had everything standardized. Right? The first part is always initials. That's not true. This is not going to work. The second part is always corn. That's not true. This is not going to work. We split things apart with underscore, not empty. That isn't true. This doesn't work. So we're going back to the, you need to have your protocols established in the beginning. Otherwise, any sort of automated analysis is not So let's use the substring out of context a little bit because it's a very useful thing. Let's go ahead and if you just do sub str and put here, I don't know, good day. Substring waits for where to start and where to end. So I want it to start at the first letter it sees and finish at the fourth letter it sees. Let's see what this one is going to give us. Whoops. Good. Right? What if I want to do from the first to the fifth? Still going to be good, but if you notice closely, there's a empty right there. So the fifth character here is that backspace. It's the empty. If I want to start it from the third and go to the fifth, or to the sixth, that will be easier. Right? OD underscore D. The substring looks at, a concatenation of basically characters, and it keeps the characters you tell it to keep from the whatever to the whatever, including those two. Right? So the way that I used it, you could have written corn 1, 2, 3, 4, 4, or whatever. So when I do from 1 to 4, I disregard what comes after corn, and the answer just well, corn, not gorn, but you get what I'm talking about, right? So that's how substring works. It takes in, whole sentence if you'd like, and just keeps whichever characters you tell it to keep. And it goes from this to that. Right? Now, the string split on its own, well, let's work on that. str split. How about I string split corn by using 1? So now what this one is going to do is it's going to take corn 1, 2, 3, 3, 3 and split it using the character 1. So every time it sees a 1, it's going to break it apart. So if you want to see what's going to be the first split, you just do 1, 1. And this one will be just corn. Whoops.
There's an I.
Yep. Up. There you go. So this split corn 1, 2, 3, 3, 3 into corn, and let's find out what's the second one. It will be 2, 3, 3, 3. Right? So it split that big thing every time you saw a 1. Okay?
I have just like here we have this corn 1, 2, 3, 3, 3. Right?
Mm-hmm.
So we could not use the first number, right? When you have like str splitting corn on, and then you close parentheses, and then you come with 2 numbers, right? We should do the column, the row, or the row and the column.
Are you talking about the string split, or are you talking about the substring?
No. It's about this one.
The string split just looks for a special character in it that you wanted to use. Yeah.
I got you. But like after the parentheses. So you have like 2 numbers, right?
Right.
One is the row, the other one is
the
column.
One is, so this one, the string split creates a bunch of stuff.
Yeah.
A bunch of things. This number 1 tells from the string split output, just focus on the splits themselves. The list of splits is saved as bracket 1. Okay? So the string split has a lot of output.
Okay.
The first thing that it outputs is the splits the way that we have them there. The second thing that it outputs is where the splits happen. The third thing that it outputs is what is the splitting factor. It's got a lot of stuff.
Okay.
So the moment that you put 1, 1, 1 is you say from the string split, I'm looking for the types of splits that you got. And then it just goes 1, 2, 3, 4, 5. How many splits happen? Okay, so that's why it's a little bit of a weird notation. There are more things that are coming out of the string split, not just the splits themselves. And you go to that by just doing this bracket 1. It's not a rows and columns. It's the first type of output that string split outputs, the first, second, third, fourth, and so on. Right? Yes, ma'am.
So up in the for loop, so the bracket 1, bracket 2, and then comma 1, comma 4. It's the bracket 1, 2 that is responsible for cutting off the number of corn.
The 1, 2 is the one that keeps only the name corn out of it. Now, if that one was not corn, but it was corn 1, 2, 3, it would have saved in there as well.
Right.
To cut it down to corn, that's the 1, 4 that follows it. Start from the first character of what you see and finish at the 4th character of what you see. And theoretically, that should be corn. Okay? Very good. So now that we run this, we created some clear files. Now, remember that we had said we need your initials. All right? Your initials should be just 2 letters. I mean, if your name is more elaborate than that, just figure out 2 letters. One to signify your first name and one to signify your last name. And I know that a lot of you guys are like, mine doesn't work like that. Well, yours should conform to that. Sorry. Choose 2 letters. That's just about it. So the next part of the code checks to see if you actually did it using 2 initials. Splits that clear files into 2 pieces. The correct answers. And again, I'm doing this to also show you a way to split a data set, right? This is independent of what we're doing here. It's mostly the technique. Subset is the tool that does that trick. So subset is an excellent command. You just tell it what data set you're trying to subset and based on what assumption. So subset says, create a new data set called correct answers by subsetting the initial set called clear files by looking at the number of characters in the name. If the number of characters, and char for short, in the name is 2, that's a correct answer. If the number of characters in the clear files is not 2, and look at the not 2, it's like a exclamation mark equals 2, that means not equal to 2, then put it as a wrong answer. So let me run these two. This is actually the first time I found an error, and I thought, yeah, that's a cool way to showcase how to split subsets. And so what you're going to end up with is you're going to end up with 2 data sets. You're going to have the same amount of variables as the original one, but one of them is going to be called correct answers, the other one is wrong answers. Run these next 2 lines and check the results. Click on the right hand side where you see the correct answers and click on the wrong answers. Again, subset is a very, very important technique in data. You need to be proficient in data set based on some requirement. In this case, I want the number of characters in the greater name. And you can dream of whatever you want. The name should start with 5. The name should start with any kind of logical argument you think of. You dump it on the second argument of subset. And now, the correct answers are these. Okay, so all these folks answered correctly, and there's one person that used more initials, and that's fine. Just make sure next time you just use 2 initials, all right? Just the one that would stand for your first name, the other one that would stand for your last name. Agreed? Finally, all of this is something that resides into R, which means that if I want to share it with somebody, I must make sure that the other somebody has R. Also, the other somebody knows R. Yeah, you don't want to do that. You want to make sure that the output is something that's readable by more people. Okay? We said last time that, yeah, Excel sucks, but a lot of folks know how to use it, all right? So it is a good idea, your output, to be something more global. In this case, what I'm going to do is I'm going to keep the author's names that did it right and did it wrong, and save it as a text file, if I remember correctly. Or as a CSV file, I'm sorry, as a CSV file, comma separated value. So I'm sure that even if the other guy does not have R, they can still open it up with Excel. So the last part, which I strongly urge you to include in any of your codes, is basically save the output as a CSV file. The first 2 lines, and again, this is an interesting stuff. The first 2 lines basically scrape the names of the ones in the correct and scrape the names of the ones in the false. There are tons of ways to do that. I could just save that last variable, but I want you also to understand what are the levels, what are the factors, and so on. So the last column is basically categories, right? They were the initials of everybody. But in R, there are special ways of doing categories. One of them is doing them as factors. That is especially handy if these names will appear over and over again in that column. And if you want to tie that to a person, for example, you have multiple lines tied to a person. You want to do that, you want to give a special meaning to those categories. You don't just want to see them as, oh yeah, that's a variable. You want to see it as something interesting about that. Then is when you turn your variable into a factor. It also works very well if you want to do graphing. If you want to do graphing by person. If you want to do that, the person should be factors instead of just themselves. So to change it, As character makes it to a character if it's not already. As factor makes it into a factor. Okay? So I take the creator name column. I'm making sure that it is a character. If it's not a character, I turn it into one. So as character turns into a character. Then as factor turns it into a factor. Little problem with R. If you try to turn numbers into factors, sometimes you get confused. So turn them into character first and then into factors. Just a little inside trick. Every time you want to turn something into a factor, turn it into a character first. Its number is still going to say nothing breaks, right? The number is still going to be a number. It's just that you don't get errors. So if you want to convert something into a factor, convert it into a character first. Just a little trick. I've seen this happen. Yeah.
You copy and paste.
Yeah.
You're looking at the date and then type character.
Precisely. So it's those little things that you get out of the screen. You do it a couple of times, you're like, oh wait, do it in the character first, it's not in the comments. True. Alright, so that's what I'm doing here. I'm creating everything and making them into a factors. So if you want to see the different outputs in that factor, the command is levels. Levels of the factor just tells you what are the outputs in there. And I do this for the correct and the wrong. So this creates two new lists, the author, two new vectors, authors correct and authors wrong. And then finally, last two lines of code, the write.csv. This is interesting also because this will allow us to add stuff using variable names. So what I'm trying to do over there is I'm going to try to get these two and write them on a CSV file. The command is write.csv. And if you just go ahead and put write.csv, the name of the variable that you want to save, and where do you want to save them, it's just going to do it. But I want to be a little bit more sneaky about it. Instead of just putting the name of it, I want to put it in a specific folder. I also want to put today's date. All right? Because remember, I mean, we might change it next year. We want to have next year's date on top of it. So first off, in order to define where to put it, you need the file equals blah. Paste 0 is this nice command that allows you to take a stable part of the code, or a stable part of the path, and add a variable path. So paste 0 here takes this part of the path and then says put as a variable the system date and end it with CSV. So paste 0's syntax is, something stable, comma, variable, comma, something stable, comma, variable, comma, something stable. So between commas you can put whatever you want. And what it's going to do is going to concatenate all of them and create one path. If you want to move inside, / is going to move you to the inside folder called results. If that folder is not there, R is going to nag. So make sure you create a folder results. The one that I gave you already had a folder results. So what these are going to do is are going to save those lists into the file inside results called perfect score list using today's date and .csv. Let's go ahead and run these two. All right, and then if we go into our results, you will see that you have two CSV files. And let's click on the one that has today's date. The one that got a perfect score. So these folks got a perfect score. And then there's the other one. And this person got a personal trip. Okay. All right. Once again, I'm not giving you this to marvel at the code. You have a lot of bits and pieces that you might need for other things. It also has little shortcuts or smart things that you use in practice. I strongly suggest putting dates somewhere don't really like the way that it puts it in there. And you can change the output of how it looks like. It only like flashes or but I definitely would like to do those because, for example, I did this a week ago, or whenever it was, on the 22nd. I want to see if somebody fixed it. I want to be able to use it next year, get the exact same output, but I don't want to be confusing with the last year. Right? I'll have to do it. Going back to the protocol that we discussed. And also, very important, everybody can read this. You don't really need R, because I can be like, I can have a TA and right, go and find those and put them in those. The TA doesn't have to run the R code, right? Are you with me so far? Fantastic. All right. Now, so that completes, the analysis of this code. But mainly, what I want you to keep from this is the bits and pieces, right? How do we do this? How do we do that? Step by step. Run the code one by one. Put comments, okay? And if you do that, then you should be able to handle today's homework. Before I get to today's homework, another thing, when I was writing this code last semester, I was, let's say, on line number 35, and I'm like, why am I even doing this? I can just look at them and figure it out. And there are only 10 of them. I could just look at those 10 names and, grade them immediately. Why am I writing 40 lines of code? And the answer became clear this semester when I just pressed the button. And it's going to be even better next semester when I just press the same button. Right? The idea is, first time you do a task, it might be counterintuitive to write a whole code for it. First time you do a task. Because come on, it's only like 100 entries. I did this experiment, I have like 50 plots. I'll just do it once and I'm okay. Yeah, great. But then you might have to do it again next semester. Instead of doing it again in fact next semester, if you spend a little bit of effort from the beginning, opening things up, making the size, using the same naming protocols, right? If you would invest 2 hours in the beginning, you need it forever. If you use the same name, I will be using the same naming protocol until like that. Every time I'm going to teach you stuff, I'm going to do it like this. If I find a better naming protocol, I'll just append my code to it. And I'm going to be able to grade my homework by pressing the button every time. So, and this is general advice. If it seems counterintuitive to spend 2 hours to solve something that only takes 50 minutes, yeah, then it means 50 minutes in the future. You say 50 minutes every time you have to do this task. If I teach this course like 4 times, my time is well spent. That's the mentality of digital life. That's the mentality of automating. I do it right in the beginning, I write in the code, and I go out and see it back. Okay. It does not work if next year you change the measurements. It does not work if next year you conduct the area. It does not work if next year you change the names of things. But it will work if you keep the same.
What about if you want to say those names, but let's say it's last 1,000 people, and there's a lot of initials,
right.
You want to distinguish between.
We mentioned that. We said if that is the case, you also have a number attached to it. The name protocol, look it up. It says AG1. That was the normal. So the first person that sets up the initials is AG. In this class, but if that is the case, then you satisfy the name.
And it was pretty
It will work. It will work. I would have to adjust it there and say it's 40 letters. The number of characters is still. Again, it's just one adjustment that I need to do. So again, I invested an hour to create this code, but now it's going to work forever. Okay? And you can also claim that maybe you're not going to be using R 10 years from now. Sure, but I can create a similar code in whatever language you choose, as long as I have the blueprint, right? So it's independent of languages as well. You can write the same code in Java if you like. as long as you do it right. Great. Let's close this down. Let me talk a little bit about homework 2, and then the rest of the time, I'm going to try to install Python. All right, so in homework 2, that's again, I'm going to do a couple of them like this. The whole point, one of the objectives, I'm sorry, for Digital Ag is to make sure that you guys can collaborate online. Gone are the days where you sat down with your advisor, you did a couple of stuff, and paper came out. Now you might want to communicate that to another collaborator who is in Kansas. I actually have 2 collaborators in Kansas. This is why I'm bringing it up. And we're writing a paper together, and data has to flow back and forth. And of course, we have a Google Drive for it, but we also need to meet occasionally. Now, things got hairier because my graduate student from last semester is in Atlanta. Last semester, me and her would sit down and call the friends in Kansas through a WebEx or whatever. We got things sorted. But now my student is in Atlanta, they're in Kansas, and I'm here. So we have like people all over the place trying to get things organized. You understand that if we had, and we're writing papers together, which means that different versions, updates, it would be a mess if we were trying to email things back and forth. So, next assignment is quite simple. You got to follow these instructions, download a couple of data sets, and create some very, very simple statistics. And I can give you how to do them. They're already in that folder. The problem is, you got to do it with a partner. The bigger problem is, you cannot talk to the partner, text the partner, email the partner. You still need to do it. So, let's try to explore many ways to communicate with folks online on a project. So I strongly suggest create common Google Drives. I strongly suggest looking at things like, Skype or WebEx or something like that, because they also allow you to share screens, something that an email does not do, something that you cannot do over a phone. So I would like you to practice a little bit of that. You should know that the university gives all the LSU students free access to WebEx. And I think, no, it's only the professors that get Skype for Business, but still, even the normal Skype in a one-to-one correspondence, you're allowed to use your screen and share screens. So the next assignment basically asks you first to find a partner online using the forum that we have on Moodle. It tells you how to do that. And then do a little bit of analysis, which basically is a joke analysis, some side-by-side box plots, and another box plot over there. So the analysis itself should be straightforward. And some people were asking me last year, like, how do you even know how to do this? I would just say, Google it. The moment that you Google our box plot, you just get examples upon examples of that. It's really not going to be the issue, right? Your graduate students, you'll figure this one out very easily. The links that I gave you also earlier on last time, the cookbook and all that, go into details on how to do box plots. I highly doubt that that's going to be a problem. Still, you can ask me questions about it using the forum. The main thing for me is find a partner. And how do you find a partner? You follow these simple details. You go to this section, has a forum, questions about R. If there are no available partners, create an entry with your name and say, I'm available. If there are available partners, respond to their entry and say, this entry is closed, you just became a team, and you can use that part to start initially the conversation. Maybe exchange Skype names or WebEx names or something like that. No emails, none whatsoever, no emails. Do that for me. No texting, no meeting also. You're not going to meet the other person in person. Everything has to be done online. That's actually the object of the homework is that. It's not to do the analysis. Even if you don't do the analysis and say we could not do the analysis together, you still get a perfect score. As long as you do it together and remotely. Say, I spoke with my partner through WebEx and we were able to just do the first box plot. Great, you got perfect score, right? So, then it tells you to go to this data set and download these the CSV files that we generated last time. And it tells you to, from each data set, just remove a couple of them, just keep the only ones you want. You can do that with anything. I would strongly suggest you do that through R. Just learn how R drops variables. If you can't do that through R, that's fine. You can do it with Excel. It's okay. Then you need to put another column called year. It was 3 years, I guess, or 4. I don't remember. Just put that to appear somewhere over there. Again, you can use some of the information that we did today. Today we created a column that was all zeros. And guess what? If you just put 2015, it's going to create a column that says 2015 everywhere. Done. You created a year. Right? Do these little tricks, and then put all of them together in a big table. That I want you to do in R. But if you look, we did the R bind as one of the commands that we learned in the two files today. And then call this big thing harvest. Include both your initials in your naming protocol, and that's one of the things that you're going to have to put up here. I'm pretty sure all teams are going to be able to do that. And then some summary statistics for the corn, and save it as a CSV file. You have to put up there. Now, what I want you to do at the end is submit your code by clicking here. There's going to be a submission button that's popping up in a little bit. Click that there, and you'll be able to do it. You could always ask for help, and you should definitely work with your partner. I don't want this to be a one person does everything, the other person just rides along with him or her. Okay? I want both people to contribute. You might want to split the tasks. You can do that. One person could be doing the merging, the other person could be doing the analysis, or vice versa. But I would like you to try to communicate without using emails, phones, personal contact, and that's it. Use WebEx or
So
Skype.
when we put the distance scores,
You just became a team. You can use that part to do the initial communication. Yeah.
I'm not Skype works. We just put a username.
Yeah, you create your username and you just send it to the other person, and just a little hello. So that's another thing. I mean, we're living in an era where online communication is going to be the norm in a little bit. It's like people are going to move away from their phones, not the smartphones, their actual phones. They're not going to be calling anybody. That's going to be expensive when you have voice over IP and you can Skype somebody. And the other thing is, over the phone, you cannot share information except for like voice. With Skype, with WebEx, with Anaconda, with you name it, you can share things like you could be working on a project together. You could be literally writing code at the same time. WebEx and Skype doesn't do that, but there are implementations where you could actually interact with the other person's screen, if you like, with the other person's terminal. So both people could be working on one person's terminal through some other online applications. And we're moving towards that. And that's going to be the future of collaboration. I don't think there's going to be ever emails floating back and forth after like 15 years. With, oh, here's the Excel sheet. That's not going to happen. It's probably going to be sitting somewhere and people are going to be adding to it and so on and so forth. I'm saying 10 years. Let's make that 50 years. Because I don't know, like people are kind of stuck in their ways. But let's say when the new generation becomes old generation, I'm pretty sure they're going to be using applications like this. All right? And I want to be on top of that. All right.
Are we allowed to use the doc?
Sure, absolutely. No emails, that's it. Just some other form of communicating things like that. All right, now, in the remaining time, how many of you guys have your laptops with you? All right, let's try to install Python. All right. I'm not moving away from R. I'm going to be revisiting R over and over again. But as I told you, I want to give you as many programs as possible. And I just want to make them work in the beginning. So, let's get started with Python, folks. If you go back to Moodle, and you click on the Getting Started part, it would take you to this. All right. What is Python? Feel free to check what Python is by clicking all these buttons over there. It's basically a programming language, right? It's getting traction lately because it's really good and for doing any sort of analysis. It's not faster than other programming languages is comparable to your Java or Perl or whatever. And it's based on scientific reasoning mostly rather than, oh, I'm going to read it. It's mostly for analysis rather than, cool, beautiful stuff. So it's not Java, but it's equally powerful. Now, Python is vast. It's just like R. It's ever expanding. It's got a lot of libraries, which in this case are called packages. That's the same thing. And so it's extendable, right? You start with a core thing in Python that doesn't do much, and then you start adding things to it. Instead of doing that, you can start with an implementation that has a lot of packages pre-built in. That's what Anaconda is. So Anaconda is a collection of Python interpreters, packages, and a graphic user interface so that you can do this faster. Okay? You don't have to download everything. So click on the second link. That talks about Anaconda. So Anaconda is a library Python. But on the other hand, it's better than that. And before I move forward, notice the first curious thing about Python. There's a Python 3.7 version and the Python 2.7 version. Right. What's up with that? Okay. When I first learned Python thousands of years ago, I also got started with that. Back then it was like, but it was still a distinction of well, no, which one of the two is better? It doesn't work like that. Here's the idea. Python started off together, and remember, we were talking about versions coming out, and we've got the same version control, and new update comes out, at some point in the past, there was a break in the community. So some folks wanted to make Python more common, more, user friendly. So they went out and started changing a little bit the code, making it more intuitive. I think that's all. Intuitive. So they break off. That community broke off and they created their own version, which at that time I think it was 2.5. And it's not like it's not Python anymore, but it's different. The syntax is slightly different. The way that they vocabulary is slightly different. The writer is slightly different. And so both of them are using the same language in the back, but they're slightly different, and they don't want to merge because folks that were writing the packages in version 2 never bothered to update in version 3. And folks that are writing things in version 3 don't really care about backtracking in version 3. Now, the trend is more and more people are moving to version 3. There's a lot of young folks who learn that in the computer science classes. So if you're taking a computer science class, of course, first thing that they're going to tell you is that tons of beautiful packages are doing 2, you should know them. And that's what I'm going to tell you. I don't think any of the packages I'm going to show you here is written 2 point whatever, but if there's one that we might see in the future, it's still not a big deal. So that's what's up. It's the same language, it's just that the one split now does not really inform the old split. And you have people that are narrow-minded that are only writing in 3. You have people that are narrow-minded that are only writing in 2. And there are people that make packages. All the packages that we're going to do work with 3. So go ahead and download Python 3.7 version. That's it. That's what's going on in that. That's why they're good. It will be impossible to install in these computers. It only works if you have a laptop. So you go home, you get the laptop. For now, for those of you that don't have a laptop, we can just check a little bit what's Anaconda. And this one will take a while to get. You need to give your email for that to work. Actually, Anaconda is not bad. Yeah, we're going to be doing something with that. The more we don't have a class, I'm going to be giving that out to So yeah, I'm gonna. Sorry for scaring you about the deadline for homework two. I have not. I was kind of hoping that we would go through that last time and we weren't able to get that next Monday.
So what do we say we do? We ask for our role. Should we say academic?
This is basically they're keeping some information for me. They are not, as I said, I've gotten a lot of spam email from others and Anaconda folks are not. They won't send you things like if you like to buy it. Alright. So once again, what is Anaconda? It is a collection of useful packages. It is, everything that Python needs to run. And it also has two graphic user interfaces that we're going to use a lot. Jupyter Notebook, which is the primary thing that we're going to use to write Python code on, and also Skyward, which is not. It also has our studio in there, and all. But we've already told that. Based on your connection. So
everyone knows.
that's also 10 minutes. Yes, that seems right. Of course, also you need to download the right version based on your computer, either 6432. Get that. And definitely doesn't work if you use your computer if you don't have the privilege to install it. So we wait for the and it's going to say, would you like to install this? Yes. How about you try it? Person can fail because
No. At the very end, it just asks like something,
Very
and then
end?
it says yes.
That's what I'm saying.
Admin something.
Okay,
It
so you
asks
don't have to write.
yes, and then you need to put your admin.
Yeah.
You won't have
That,
that.
that's what I would do. Alright. As we're waiting for that, let's click again on Moodle and check a few more things about Python. One of the, actually I have Python, so I could just be showing you a couple of these things. So when it installs, you're going to be greeted with an environment that looks like the one that's going to pop up in a second. So, still big stuff.
I've never seen this computer. But I've never seen this. It's probably with problem with JavaScript. I've never seen this.
You install,
I've been using this for a while. I just need it. I tried, man. Yeah, this is what happens. So I tried. I said, this is actually a trap. And it'll pop up sometimes.
something wrong in the background.
Yeah. Okay. Let me cheat sheet.
Have you installed it? Or are you installing it?
No, I had to run this install it. I think we were using it before.
Just go up to
So it's important. chance what your antivirus is about. How about deleting one and virus? Yeah. Is that what I was install. Install it. Oh, good friendly thing. Run it. Yes. First one. Install. Yes. Huh? Still, no. It's still locked by value. After install this whole thing. What if you just like let it go? So I'm gonna try this for you. Yeah. I've never seen this before. I reckon uses this.
There is a different version of Anaconda each time. So let me show you how it looks like. Then it's going to pop up. And then, okay. When everything gets installed, once again, this one is basically just the dashboard, right? In the background, the engine, Python is always installed. And these are basically little programs that will help us interface with that. The Jupyter Notebook, the second from the left on the first row, is the one that I'm going to use for codes. I'm going to do that a lot. Spider, the fourth from the top, is another one we use to create codes. And those come pre-built in. As you can see, you can even install RStudio. This is not there. Or you can install Glue V's to create visualizations, or Orange 2 again for visualization. So, I'm not going to be running any Python code today. I'm going to make sure you have it downloaded. And I also want to show you how it's going to look like. This is what you should do. If you don't get one of those, you did not do it. That's how it looks like in Vue. Now, I would suggest spend a little bit of time looking at, boom, they're getting started. The moment that it opens up, you will be, as I said, greeted with these programs. The one that we should be working on is this Jupyter Notebook. And Jupyter Notebook, basically it's an editor, right? You can write code in it, but it also has, press a button and it runs it. Press a button and it gives you the output. It's like RStudio, if you like. The cool thing about it is that it is using your web browser. So these folks are very smart, the ones that created Jupyter Notebook. Instead of creating a program from scratch, like RStudio, they said, okay, I'm going to hijack whatever your browser is. Google Chrome or Firefox, because those are the only two browsers you should be using, right? Safari if you got one of those Macs. Once again, the default browser that you have in Windows is just for you to go and find Google Chrome and download. That's the only use of it. As a matter of fact, Jupyter Notebook does not work very well with that default browser, which I'm not even going to name. It's like, that thing sucks a lot. It sucks. Just download Google Chrome, please. It's like, just download it much faster. Anyway, so Jupyter Notebook, instead of creating something from scratch, as I said, they repurposed that browser. As you can see now, I'm opening it up with Firefox. And all the buttons and all that stuff are written with bits and pieces from Firefox or whatever browser you're using. I thought that was really cool. And again, you can create new stuff. This one is for Python 2 and whatnot. We'll get to that next week. But this little introduction tutorial thing, it's a YouTube video, is something that you could be looking at. That's how we're going to start next Monday. So install your Anaconda, and to test if it's working, fire up Jupyter Notebook and try to see if you can follow this tutorial. It's not a big one. I think it's like, you know, it's got multiple ones, but this specific one is 30 minutes. And just follow along with this guy. Does a pretty good job at, you know, talking about this simple stuff, right? And then I have some other links here. This is a cool little book that you can find here. It's completely free online. If you want to automate the boring stuff with Python. I've used this when I was first learning about Python to write this little script that would scan the homework problems of all the students and make sure that the pages were right and everything was right. That was an easy thing for me to figure out who did not do the homework. Because like 95% of the cases, it's either you did the homework or you got a perfect score. Or, sorry, you didn't do the homework or you got a perfect score. So I had the sorter first. And then I basically looked at the ones that didn't give me like 4 pages. It gave me like 2. And I looked at those, and then it gave perfect score to the rest. Don't tell that to my boss, but and I wrote that in Python. So it's got a lot of cool little things. I liked it. I'm just giving it to you guys completely free up here. The Think Stats with Python is another book that the library suggested. And again, it's completely free. You can click on all the things here. You can figure out how to do simple stuff. All the things that we were doing in the 705 class, if you've taken that, you can do it with this book. So back when I'm teaching the 705, I teach it in SAS and I teach it in R. If you follow this book, you will be able to do it in Python as well. And it's a cookbook type of thing. If you want to do this, you do that. It's example. Just download this data, put it there. It's very nifty. Yes, sir.
What are some of the advantages and disadvantages of using like SAS or R? Like, when would you use one over another, or just personal preference?
Yeah.
They all do the same.
Yeah. Yeah. I mean, I'm trying to keep an agnostic view of everything. Like I'll use whatever's needed, right? I mean, there's no package that does that in R. Maybe there's one in Python. Oh yeah, there we go. Okay, fine. Where are you going to do the pre-processing? Oh, I'll do it in R because I've done it in the past and I have the code right there. I'll do it in Python because it does it faster. So completely agnostic. Notice in that sentence I never mentioned SAS. So that's it. Basically, yeah, be agnostic on the program. Just do something. If you've done it in the past in R, do it again in R. Why not? If you are trying to do something that's very, very simple, yeah, you can use SAS. Like create a histogram, proc univariate, done. Does it. If you're trying to do a neural network, do it in Python. It's going to be faster. If you're trying to do a random forest, do it in R. Because the package is simpler. Things like that. Finally, there's this Think Python. Wait, nope. Yep, Think Python. I think it's the same guy that did Think Stats in Python, and it's just more elaborate. These are from the library. The library told me like these are the 2 that the library gives out, and you can find them in the library if you want to have the hard copy. But I don't know why you would want that. Just click on these and you can do these in Python. So. For next week, make sure you have downloaded Anaconda and it looks like this. Alright? And then fire up your Jupyter Notebook and don't be scared if it hijacks your browser, which is going to look like this. And then spend 30 minutes with this guy and try to figure out how to basically write a very simple thing in Jupyter Notebook. That's it. Very good. I guess that's all for today. As I said, use the Moodle chat room to find a pair, and go ahead and pair up. Your homework number 2 is going to be due next Monday. I'll fix that right. Cool. I will see you next Monday. No class tomorrow.
So you told me what, like, just try to get the